So far, we have covered how to write an equilibrium expression, which is simply K, which is equal to the products over our reactants. The products over reactants gives us a ratio of how much products over reactants we expect to have at equilibrium. However, what if we are told a concentration of A and B, and it is said that we are not at equilibrium? In this case, instead of writing an expression for K, we have to write an expression for Q. Q tells us where we are in the reaction at this given moment. So while K tells us the ratio of our products to our reactants at equilibrium, we can think of Q as a snapshot in time of where we are at this given moment. So maybe this is our initial concentration of A and B, or our concentration of A and B 2 minutes after we start the reaction. The only thing we need to make sure is that we are writing a Q expression when we are not at equilibrium. So at every other time besides equilibrium, we are writing a Q expression. And when we are at equilibrium, we are writing a K expression. So Q is written the same way as K. It is still products over reactants. And it follows the same rules. You cannot write any solids or liquids in your Q expression. And whatever coefficient you have in front of a reactant or a product, you would simply raise it to that exponent in your expression. So in this case, it would be concentration of B over the concentration of A. Now, say we are told that initially we want to run this reaction until it gets to equilibrium, but the initial concentration of B is 10 molar and the initial concentration of A is 5 molar. Well, the word initial cues me to know that we are not writing an equilibrium expression because this reaction hasn't got to equilibrium. We are writing a Q expression to know what is going on at this given moment. So I would write 10 molar over 5 molar, and our Q value would be equal to 2 at this given moment. So in the next video, I'm going to be going over the interplay between Q and K and how reactions are going to proceed based on the Q and K value.